Jain to all of you. Myself Jaishree Jain, Assistant Professor in Department of Computer Science and Engineering from AKGEC Engineering College, Ghaziabad. So today we will learn about the in image processing, what is the image segmentation. So we understand what is the requirement of the segmentation and what is the role of image segmentation in image processing. So what is the purpose of what is the purpose of image segmentation? Segmentation means like we are going to divide our image into different partitions so that we can identify the different objects from the image, because we know in an image there is a background and there is a foreground. So at the background there are some colors, or there are some edges there, and at the foreground there are some objects there. So we have to identify, basically we have to identify the object. So for identifying the object we are going to partition our image, so that is called as a segmentation. And there are various segmentation techniques, so that we can apply different technique and can find out the accuracy, what is the basic accuracy of the image, so that we can identify the object clearly. So basic purpose of this is to identify the object. So we can partition the images based on the, might be there might be possibility based on gray level we are going to partition our image, or based on the color level, like red channel will be divided into one segment and green channel will be belong to other segment and blue channel will be other segment. So there are different parameter on which we can divide our images into different segments. So gray levels can be there, color can be there, texture can be there, and there can be any depth or motion in the image. So these are the different parameter by which we can apply different technique on the image for segmentation. So these are the basic step of the segmentation. Like if I have given one input image, so first step is to apply image segmentation, through which we can partition the image into different parts. And after that the segmented parts will be going to annotation of the object, means we will recognize the object and give the annotation, means we give the number object 1, object 2, object 3, how many objects are there. Like in a scenery, or like in a car parking system, we can identify how many cars are there in the parking system. So annotation means we can count the number of objects, and after that, like object quantification outcome is there, like we have quantify how many objects are present in the image. After that we will extract the features of the object, like car size or color or type of car. Like so we can extract the feature and we get the feature vector here, and after that we will apply the classification and clustering algorithm over there, so that we can classify number of object belonging to one class, another object belonging to other class. After that we will identify the final result. So this is a typical image analysis pipeline. So for this process is basically used for image object identification that is hidden or that is occurring in the particular image scene. So we have to this is a step. Next, there are different technique how can we segment the images, and how can we group the similar object into one class and other dissimilar object into the other class. So we have to just combine, we have to group the similar component such as the pixel in an image or image frames in a video. If there are similar pixel in an image, then we classify those pixels and belong to the one group. And after that in a video the similar frames are being collected and will be placed into the one segment. So we can segment these images based on the similarity. And other method is so based on similarity we can find out the different method like thresholding or k-mean clustering method. So actually in image segmentation we can say there are two basic methods based on similarity and based on dissimilarity. So if we are taking the similar component, then these are the method thresholding, k-mean clustering method can be used to find out the image segmentation. Next is using image segmentation, initial and vital step in the series of process aimed at overall image understanding. So basically it's already clear why we are performing the segmentation. So this is the similarity based segmentation. So we have two applications of segmentation are identifying the object in a scene for object based measurements such as size and shape. So I already told example of car parking system, and we can find out the in a moving scene we can identify the object for object based video compression, and identify the object which are at different distance from the sensor using the depth measurement. So I have already told we can choose different parameter like grayscale, color, depth. So according to these parameter, different objects can be identified according to the conditions. So these are the applications. Next, definition I already told why we are. You can read and understand what is the purpose or process of image segmentation, like partitioning of an image into the non-intersecting regions, and such that each region is homogeneous and union of no two adjacent region are homogeneous, means each segment will be in separate, and those there are no common feature or pixel present in the both segments. So non-adjacent, no two adjacent region will be homogeneous. Next, image. So I already told there are two methods of image segmentation based on discontinuity and based on similarity. So similarity means we are combining the similar objects, similar pixels or similar frame of in a video. So these are the method. In the case of similarity, we can apply thresholding method, region growing method, region splitting and merging method. So these methods are used for based on similarity, and in case of dissimilarity we can have three method based on isolated point, based on lines and based on edges. So there are three conditions. If we can find out any isolated point in the image, then we can separate that point from that image, or there can be different lines in the image, so we can separate those lines into the different segment. And in case of edges, we can find out the sharp line. Edges are what? Boundaries or sharp lines. So we can identify those edges and separate those edges from the image, so that belong to the other segment. So these are the methods when we apply the image segmentation. So this is a simple example. This is the original image, and we can this image have this is the background of the image, and at the foreground we have the rice grains. So we have to just identify count the object. So we can apply the threshold, means we can give the value. If there is 0 means not a rice grain pixel, and 1 means rice grain pixel, means we have to classify whether its background is black or white. If it is white, then we can say it is 1 and rice grain pixel is there, and if background is 0, then there is no rice pixel. So we can partition the image based on the segmentation rule. Next, segmentation techniques. So the first technique, based on similarity, we can apply the thresholding method and region splitting and region growing method. So first method is thresholding method. So thresholding method means we have to choose one adequate threshold value t, so that we can separate our object or our foreground from the background. So this is very useful technique if we want to discriminate between the foreground and background process. So in this case, there is a formula. We have to choose one threshold value and compare the pixel value from that threshold. If that value, if fxy means the original pixel value of the image. So fxy compared with the threshold value, if it is greater than threshold, then we can say the value of gxy will be 1, means gxy means that is the segmented image and this is the original image. And if fxy is less than equal to t, then the gxy will be 0. Like rice grain example is there. So we can separate these pixel into 1 and 0 by comparing the pixel value from the threshold. Like if pixel value is 0.5 means at threshold value is 1. So 0.5 is greater than 1. So we can apply the value that is 1. So that's why We can take the example, and this type of thresholding is called as a global thresholding method. Global means because we applying this process to the whole image pixel. So this is the global thresholding. Next is, so this is the thresholding method we can apply to the overall image. And the application of this is the example when we apply the threshold here. So we can find out the threshold value. We can choose a threshold such that we can compare the foreground with the background. So here these pixels are collected here, these form the background of the image, and these form the foreground of the image. So we compare, and threshold value is between these two. So we can separate these objects can be extracted by comparing the pixel value with the threshold value. So image with dark background and light object. This background will be dark, that is belong to class 0, and this background is light, means that belong to class 1. So this is the example we can see with the graph. This is the object and this is the background of the image, and these are the different pixels. So we can also apply multi-level thresholding. Multi-level thresholding means we can take the 2 or more threshold and compare the image pixel, like fxy will be compared with t1 and t2. There are two threshold value to identify two objects. Actually, if we can see in our image there are two objects, and we want to identify or separate these two objects, then we can apply two threshold t1 and t2, and we can compare our image pixel with these two threshold. If fxy is greater than t2, then we can say it belong to class A, and if this value is lie between t1 and t2, then it will belong to class B, and if it is less than t1, then it belong to class C. So we can identify one will be the background and two will be the foreground or object of the image. So this is the outcome of the formula. Like we can see image with dark background and two light objects. This is one threshold T1 and this is another threshold T2. One is the background, and object 1 and object 2 can be easily segmented through this multi-level thresholding. So we can say threshold can be, there can be various thresholding technique, variable thresholding or local thresholding or global thresholding or dynamic or adaptive thresholding. So there can be different thresholding method based on the application, based on the utility. We can choose different threshold. Variable threshold means we can like T1 and T2 we have chosen two threshold. So there can be a particular value for T1 and T2 can be different value. So variable thresholding can be implemented, and local thresholding means we are applying the thresholding into particular region only, not the overall image. So we can say that is the local thresholding, means into only one block we are going to apply the threshold. And next is dynamic and adaptive thresholding, means T depend on the spatial coordinate xy themselves, and variable thresholding is referred to as dynamic, means based on the pixel value we can apply different threshold value on the image. Like this, we can apply variable thresholding, like threshold can be based on the pixel value or based on the this pxy that denote the some property of the image, means gray level, or we can apply any color segmentation or based on depth. So this is a property of color image and this is the original fxy. This is a global thresholding applied to overall image. This will apply to only some segment of the image, and this will be the variable thresholding to identify different object based on the gray levels. So like this thresholding is called as a global, and if we are applying some property based on property, then this threshold is local. And if we are going to apply the dynamic and adaptive thresholding, then we can apply one of the method, and the threshold can be dynamic, means can be changed according to the condition. So this is a figure. We have the original image background with the two objects. So we can apply here image, original image is there. This is the image histogram. means we have background pixel into one part and foreground pixel into another part. So we can separate background from the foreground by applying the threshold value. So this is another example. We have noisy fingerprint. If we want to apply the in case of fingerprint recognition, so we have to separate the ridges from the background. So noisy fingerprint is there. When we plot the histogram, then we can find out the separation here. So we can choose the threshold value here. Like background is there and foreground is there. So we can choose threshold value between these value like 127. And when we compare this, then background will be separated from this object and clear image. Segmentation result using global thresholding. So the border was added for clarity. This border is added for clarity. So this is the basic use of the segmentation. We can apply the segmentation in case of fingerprint recognition, and we will find out the best fingerprint here. So adaptive thresholding is like dynamic thresholding. So it will depend, each pixel depend on the location of the pixel in terms of sub-images. This type of thresholding is called as a adaptive. Adaptive means based on the location of the pixel, means we can apply different threshold based on the location. If it is lie between 0 to 125, then we can apply one threshold value there. And if the pixel lie between 126 to 120, like 170, so we can apply second threshold value there. So this is based on the depend on the location of the pixel. So this is one example of adaptive thresholding. This is the image, this is background, and this is the foreground of the image. Then we apply the firstly we will apply the global thresholding. If I apply here global thresholding, then this will be the result of the global thresholding. So all the object will get disappear here, and this is not effective, so information is getting lost. So we will not apply global thresholding here. So we next is image is subdivided into individual sub-image. Like we have select one portion here, then we apply threshold value, one threshold here, then another value is there. So we will divide our image into different sub portion and apply the different threshold value based on the pixel location. So when we apply adaptive thresholding, then this will be the result of that adaptive thresholding. Only for this reason I have applied the one threshold value. So we will get this kind of image. Fine. So adaptive thresholding is very useful. So we can compare between the optimal global and adaptive thresholding, which will give the optimal result. So already in previous example we have seen, if we apply global thresholding, then image will get disappear, and this is not effective result. So we have to apply the adaptive thresholding, that is called as a optimum thresholding. So we can there are two kind of error, basically mislabeling of object pixel as background and mislabeling a background pixel as a object. If this kind of error occur, then we have to apply the optimum thresholding value. So gray level probability density function of two region in the image. So for getting the optimal thresholding, we have to apply the PDF, probability density function. So we calculate the PDF of the every pixel and then arrange the pixel into the ascending order. Then we can apply the threshold there. So if we have applied this is the P1Z, means this is PD probability density value of pixel region 1, this is the object and this is the background. So we can see here there is a overlap, and here we can choose a threshold to separate the both densities. So this I already told like this. So the sum of P1 plus P2 will be the 1, and finally we will get the gray level probability density function of the pixel and compare the threshold. This is a formula for calculating the error. So for calculating the error, we can integrate this density with respect to d of z from infinity to threshold. So we will get the error whether our threshold value is have separated the foreground and background without any error or there is any overlapping. So this is the formula to calculating the error, and we can change the threshold value to minimize this error. This is a Gaussian density. We can calculate the Gaussian density where this formula will be applied. This is the value of P1Z and this is the value of P2Z, where sigma is the variance and mu is the mean. So we can apply, we can choose have to calculate the statics. This is a statistical method where we have to apply the mean and variance, and after that we can calculate the Gaussian value there. Next, so this is the value of calculating P1, P2, and this is a quadratic equation for calculating the threshold. So in this case, the threshold will be chosen with the help of this formula. So this is also called as the optimal thresholding method. Next is clustering method. Clustering means based on similarity. Because we are going to understand the segmentation based on the similarity. So in similarity, we can apply the clustering based on the keyword or based on the content, like shape of the image, texture of the image, or other information. We can group the pixel into the one cluster and can apply one threshold value there. Next is region based segmentation. So this is also similarity based segmentation, in which we have to, this is the term region. Region means we have to find out the different region and then connect those region, find out the similarity between those region and can club those region into the one region and kind of segment the image. So this is the actually basic formulation. Means union I equal to 1 to n. Firstly, all pixel will belong to the same region. Then Ri is connected region between 1 to n. These are all the pixel between 1 to n. Then we have to choose Ri intersection of Rj should be null for all I and j. If we separate our region into two region, Ri and Rj, then there should be no intersection. The intersection means there will be no common pixel. And P of Ri is true for all the I. P of Ri means that is a predicate property, means based on texture, based on color, all the property of that region based on that value should be the true. And this predicate of Ri union Rj equal to false, means there will be no homogeneity, there will be no common pixel that will be in both region. Fine. So this value will be false. Next is region growing. Region growing is a procedure that group pixel or sub-region into the larger region. So if I have chosen a small area and then we can compare that region to the other region, and if I find out some other similar pixel, then I can also merge those pixel or those region to our region. So that is called as a region growing method, and we can stop that growing when we find out that there are no other pixel present in the image that belong to the similar group. So the simplest approach is the pixel aggregation. So we have to aggregate the pixel start with a set of seed points. Seed point means we have chosen a small area or region or point, then we compare those points with the other pixel. So seed points are there, and by comparing the property like gray level, texture and color and shape, we can apply compare the similarity from those seed point and then merge those region with that region. So region grow approach will be there. Now we will understand what is the basic use of region growing approach. So region growing, let fxy denote the input image, input array, sxy denote the seed array. So this is the overall image, this is the seed array, means we have chosen some point there, and q denote the predicate, means some condition will be applied there for region merging, and f and s are assumed to be of the same size. So we can apply the 8 connectivity, or we can apply the 4 neighborhood connectivity over this. So this is the image, X-ray image, this is the histogram of the image, then these are the initial seed point. We want to find out the similarity of this region. We have to grow this region. Then firstly we will apply this is the final seed image. These are the seed points, and compare the seed point with we have to calculate the absolute value of the difference between A and C. So this is the original image and this is the seed point. This is the difference. This is a histogram of this difference. Then we have to apply the threshold. So different image threshold using the dual threshold. So we have chosen two threshold, T1 and T2. So this is one reason we apply T1 threshold here, and for other we apply T2 threshold there, and find out then difference image threshold with the smallest of the dual threshold. So which value is the smallest? We have chosen those. So this is the image of smallest pixel value, and this is the segmented result obtained by region growing. So thank you so much. This is the overall part that I covered into the similarity based segmentation. Thank you.